this video, we are going to learn inverse of linear functions given its map, or given its equation, or given its graph, and how we interpret it in our real-life situations. If we have a function as we see here on this mapping, we have a, b, c. This is the set of the domain, and 1 to 3 is the set of the range. So if we want to write the ordered pairs for this function or this relation, it will be a and 3, b and 1, c and 2. So what is the meaning of inverse of this relation or inverse of this function? It means that we switch the domain and range. So as you see here, the domain a, b, c was in the function f. But if we are talking about the inverse function, which we notated by f inverse, which is f and -1 above, the domain here became the 1, 2, 3, which was the range in the first case in the function itself. So what we did is just switched the domain and range, and that now the domain is 1, 2, 3 and the range is a, b, c. So the ordered pairs, we can write it as 1, b, 2, c, and 3, a. If we compare the two sets here, a3, b1, c2, and here 1b, 2c, 3a, we just will see that we just switched, or we flipped the ordered pairs in each of them. So this means that the range of the function becomes the domain of the inverse function, and the domain of the function becomes the range of the inverse function. So as you see here, from this mapping, we have the x, which is the domain of the function f, and y is the range of the function f also. Now it becomes, for the function f of f inverse, or the inverse function, the y becomes the domain and the x becomes the range, as you see here from this arrow. So let's see how we can get the inverse of the function if you are given its equation. As you see here, the f of x equals f5x plus 10, which means it's written as in the form of the slope-intercept form, mx plus b. Okay, so the first thing we do is that we're going to do some steps to find the f inverse, to find the f inverse x. The first step, we rewrite fx as y equals, and we write the same equation, 5x plus 10. Second step is that you switch the y and x. You replace x by y and y by x. So here, instead of y, I will write x equals 5, and instead of x, I will write y plus 10. And of course, you know why I switched the x and y? Because in inverse functions, the domain becomes range and range becomes domain. Step number 3, you solve the equation for y. So we want y equals what? So to do this, we're going to subtract 10 from both sides. So here will be -10 plus x equals 5y, and then we divide by 5 to become y equals -10 over 5 plus x over 5, or which is y equals x over 5, that is 1 over 5x, this is the slope-intercept form, minus 10 over 5, that is equals to -2. So y equals 1 over 5x minus 2. Now step number 4, and the last one, is that you rewrite the y, we rewrite it as f inverse x, and we rewrite the same here, 1 over 5x minus 2. So this is the inverse function. Now let us apply this to the graph. First, I will graph the main function 5x plus 10. 5x plus 10 means 10 is the b, is the y-intercept, so I will put my point on the b. And then 5 means the slope, which is 5 over 1, that is move up 5, and as you see here the scale is by 5, so move up to 15, then write 1. So because it's 5 over 1, put another point and graph the line. As you see here, this is the graph of the function fx. Now I will graph the function, the inverse function 1 over 5x minus 2. Here minus 2 is the b, so I'll come here on minus 2. It will be somewhere here between 0 and negative 5. So it will be between 0 and negative 5 because this is negative 2. Okay, and 1 over 5 means the slope 1, move up 1, and move to the right 5 till here. So this is another point. Okay, this is not accurate, of course, but I'm trying to be more accurate as possible. And this is the line. Now, if we have a graph and we need to get the function, the inverse function from the graph, or we graph the inverse function only from the graph, what we do is that you just get 2 points that are very accurate and you switch them, the order pairs. So for example, the first one here is, the first point I can get is that point, which is very accurate here. That point is between 4 and 8, this will be 0 and 6. And you switch them to be 6 and 0, which will be here, 6 and 0. Take another point on the line to be accurate. Okay, let's take this point. This point is negative 6 and 8 will be 8 and negative 6. So 8 and negative 6 will be here. And we graph the line like that. Okay, something to be noted here, that the graph of any function and the graph of the inverse of the same function, both of them are reflections of each other. On the graph of the parent function, y equals x. So in the middle here, if we graph the function y equals x, this is the parent linear function. This works as a mirror between both functions, the function and its inverse. So any function and its inverse are reflected upon the y equals x graph. Now, where do we use the inverse function in our real life? Look at this example. Skylar and Carmen rent a paddle boat at a state park for $15 plus $4 for each hour it is used. So the function cx equals 4x plus 15 represents the total cost cx for x hours. So cx represents the total cost, while x represents the number of hours. This is in the original function cx. Now to determine the inverse function, first instead of cx I write y equals 4x plus 15. Second step, switch the x and y places, or replace x by y and y by x. So it will be x equals 4y plus 15. Step number 3, solve for y. So we'll subtract 15 from both sides. 4y equals x minus 15, and then divide by 4. This will be y equals 1 over 4 x minus 15 over 4. And step number 4, that is, we replace y by f inverse. X equals 1 over 4x minus 15 over 4. So this is the inverse function. Now interpret the inverse function. In the situation here, what does the inverse function mean? The inverse function here means the opposite. So if the original function, the c of x, represents the total cost, okay, So in the inverse function, the x itself will represent the total cost. And in the original function, if x represents the hours, so in the inverse function, the f inverse will represent the number of hours, because as we know that the domain becomes range in the inverse function and the range becomes the domain in the inverse function. So this means that, let's write it here. So this means that f inverse x means the number of hours and that x represents the total cost.